Da-da-da. All right, guys, let's begin with point number 1 here. As usual, I like to begin with the number 1 because I feel like it is the easiest. And the further you move into the exercises, the difficult they get, right? So hopefully we get to do number 4. Ooh. All right. Jacob designs a fair cubical die number within the fixed, with the first 6 prime numbers. All right. So we have a die, right? We have a die, and the die has a bunch of numbers, has 6 numbers. Now, what are those numbers? Everybody, please tell me in the chat. What are going to be those numbers? Don't say 1, 2, 3, 4, 5. No. Because if you take a look here, we're going to have the 6 prime numbers, right? So the numbers in the die are not going to be 1, 2, 3, 4, 5, and 6. Are going to be different numbers. What are those numbers, guys? Anybody?
5,
All right, 5 is one of those. What else?
7.
7 is another one. Cool.
Ah, ya los escribieron.
There, thank you, Anna. Amazing. All right. Let me write them in order. So the possible answers, I'm going to write them like this. This is the usual corchetico for sets, right? So the values are going to be 2, 3, 5, 7, 1, 2, 3, 4, 11, right? And then 13. Beautiful. Cool. These are the 6 possible values that Jacob is going to put in his die. All right? Let's continue with the example. He throws his die and a fair tetrahedral. This is a 4-side die. Tetrahedral is a die that has 4 sides, right? And those sides are numbered with the first 4 square numbers. Ooh, all right. So what are going to be those options? What are the first 4 square numbers? Anybody? The first 4 square numbers. Like this, better.
2.
All right, 2 is not a square number. No. Square numbers are numbers that are the results of elevating another number
4.
to the second power, right? So 4. Why? Because 4 is the result of 2 to the second power, right?
10.
10 is not a square number.
25.
25 is a square number. Yeah, sure. Let's try to do this in
9.
order. Let's try to do this in order, all right? Let's try to do this in order. You got the idea, brother. All right. 1 is the first.
1.
1 is the first square number. Because 1 is the result of 1 to the second power, right? 4. Because 4 is 2 to the second power.
9.
9. And then 16.
16.
Beautiful.
Ay, el chic.
Beautiful. All right, guys, take a look at this. In this exercise, even though this is an exercise about probability, we need to know 2 other things. Number 1, what are prime numbers? And number 2, what are square numbers? All right? Since you guys are studying a mathematics course from IB, you are expected to know these things. Guys, if you don't, you need to let me know so that I can explain it. Guys, if you think you know but you forgot, you need to let me know so that maybe we can, I don't know, schedule an appointment, right? A tutoring. You need to do something about this, guys. Even if you don't care about studying this with me, well, you're gonna have to do this yourself, right? You gotta go, I don't know, to YouTube or some other place and check on what are prime numbers and what are square numbers. For this example, right? For this example, all right, let's continue with this. What else? All right, so he throws the regular die and he also throws the tetrahedral die. So he throws both, right? And he's gonna write down the difference between the 2 numbers. Ooh, the difference. All right, So we have a difference, right? The difference is the subtraction, right? So for example, if the guy get a 2 in the first one and a 4 in the second one, the difference is going to be 4 minus 2, right? So 2. Did you get it? Let's try another example. Take a look at this. Maybe he gets a 7 and a 1. So the difference is 7 minus 1. For this one, difference is 6. Guys, notice how I am always selecting the biggest number first. Doesn't really matter which die gets that number. I'm selecting the biggest first, and from that one, I'm subtracting from the lowest, right? Because the difference is always positive. If I were to do the otherwise, right, the lowest minus the biggest, I will have 1 minus 7. That is negative 6. That cannot be, because differences are always positive. All right? So you have to do it in this way. The biggest number first, the lowest number next or second. All right, let's continue. Find the probability that D is a prime number. All right. All right. This exercise is absolutely beautiful. Man, this exercise is combining so many things. So many things. All right, don't worry about it, guys. Don't worry about it. All right. As usual, in mathematics, we like diagrams to express the information, right? So we're going to use a diagram here that is called a sample space diagram. Let me write it here. Sample space diagram. Sorry about my handwriting, guys. It is really, really difficult for me to write using a mouse. Sorry, guys. We're going to use a sample space diagram. Now, how is that? How do you create a sample space diagram? Pretty simple. You're going to do the first quadrant on a how do you call this thing? Cartesian plane. The first quadrant on a Cartesian plane. So just like that. An L, just like that, right? Over here, we're going to write down one of the possibilities of one of the dice. So we're going to do the first one. And over here, we're going to select the other possibility for the other dice. So this one, right? We are kind of creating a data table. All right, let me write down the values then. So for the first die, these are the possibilities. I can have a 2 or a 3 or a 5 or a 7. Maybe I can have an 11 or maybe I can have a 13. Guys, notice how I'm putting every single number that I have as possibilities from the first die. This is how you create the sample space diagram, all right? Now, for the second one, let me write the values here as well. The values are 1, 4, 9, and 6. 1, 4, 9, and 16. Sorry, 16. All right. And we are going to do little dots representing the combination. So for example, this dot that I'm going to do here, this one, represents the possibility that I get a 2 in the first die and a 1 in the second die. Did you get it? How about this little dot on here? This little dot here. All right, this little dot represents me getting an 11 on the first one and a 1 in the second one. Did you see? Every single dot that I create inside my diagram represents the possible combinations. So if I do all the dots in here, if I just do all the dots, it's going to take a little while. But if I do all the dots, I am going to be representing every single possibility. Every single possibility here. La da da. La da 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 da. Every single possibility. Look at that. Now, why is this diagram helpful? Well, because just like this, you can answer questions like, how many possibilities do we have? How many combinations? Well, again, remember, every single dot, every single blue dot that I have here is a combination, right? So how many combinations do we have? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. We have 24 combinations, right? Because there are 24 dots. Did you get? Did you get it? We can answer questions like, I don't know, how many of those combinations have an even number on the dice? This has an even number because this has a 2 and a 1. Also this, 2 and a 4. Did you see? 2 and a 4. This has a 2 and a 9. 2 and 16. Did you see? What other ones are even? This one is an even one because this one has a 3 and a 4. So one of the digits, one of the values in the dice are even, right? So the diagram is absolutely beautiful to let you see all combinations and all those sorts of questions like that. So again, if I ask you guys, how many of those 24 combinations have an even number on one of the dices? Just count the yellow ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there are 15 combinations. Did you see? This diagram is absolutely beautiful for that. All right, I know. Guys, just like I did this, we are going to highlight our question. Let me erase all the highlighting. There. Beautiful. All right. Take a look at this. We are being asked to find the possibility, or the probability, sorry, that the difference is a prime number, right? So we want the subtraction, always positive, of course, to be a prime number. These are some of the prime numbers, right? So we will need to find differences that are these values, 2, 3, 5, 7, 11, and 13. Right? Let's think about that. Whenever we find one of those, we're going to highlight it. And things are going to be absolutely simple. So for example, 2 minus 1. How much is 2 minus 1? That thing is 1, right? Remember, the difference is 1. And 1 is not a prime number, so I'm not going to highlight this little dot. Let's continue with the second one. How much? 3 minus 2. I'm sorry, 3 minus 1. This one. This one, the difference is a prime number, right? The difference is 2. Did you get it? All right, let's continue with the next one. 5 minus 1 is 4. Not a good one. 7 minus 1, 6. Not a good one. 11 minus 1. No. 13 minus 1. No. All right. So in the first row, just the first one. How about the second one? 2. Oh, look at this. It's not 2 minus 4. It's going to be 4 minus 2, right? Because the difference has to be positive. And that is 2. The difference is 2, which is one of the prime numbers. So that is another one that I want to highlight. 3 minus 4 is 1. Not a good one. 5 minus 4, 1. Not a good one. 7 minus 4, 3. Look at this. This is a good one. Right? 11 minus 4, how much is that? That thing is 7, right? Right?
Yes.
Thank you, Mafe. All right, and that 7 is a prime number. So I'm going to highlight that one. 13 minus 4, that thing is 9. But 9 is not a prime number. So I'm not going to highlight it. Huh? This is the beauty of the Venn diagram. I'm sorry, of the sample space diagram. All right, let's continue. 2 minus 9 is 7. Or negative 7, but whatever. We only want the positives, right? 9 minus 3, 6. No. 9 minus 5, 4. No. 9 minus 7, 2. Beautiful. 9 minus 11, 2. Beautiful as well. And 9 minus 13, this thing is 4. So no. How about with 16? 16 minus 2, 14. So no. 16 minus 3 is 13. 13 is a prime number. 16 minus 5 is 11, which is a prime number. 16 minus 7, that is 9, right? Not a good one. This is 4, not a good one. And 3, not a good one. I think that is it, right? So look at these guys. Now, yes, sir.
Pero el 3 sí es.
Which one? Ah, yes.
3.
In this one, right? This is a good answer. What other one? No. No. All right. Like that. Thank you, Paul. All right. Thank you, Paul. All right. Let's continue with this. Now we can answer the question. A. We want to find the probability. Look, We want to find the probability that the difference is a prime number, right? And remember, probabilities are always the same. Success over the total, right? Oh, by the way, we can write this using notation. We just do it using notation. The probability that the difference is prime. The probability that D is prime. Let me just do a little bit of a space here. D is prime. What is the probability? All right, as usual, we have success over total, right? Now, as I always say, try to begin doing the total first. Always try to begin doing the total first. And how many combinations do we have here? What is the total? Well, the total are every single dot that we have in here. Those are all the possibilities that we have when we throw the 2 dice, right? So we have a total of 24 possibilities, right? There. 1, 2, 3, 4, 5. You can count them, right? The little dots, 24 possibilities. Now, what is the success? Well, the success are the options in which D is prime, which are the highlighted ones, the ones that we already highlighted. So all we need to do is just count the highlighted. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So the probability is 10 over 24. And just like that, we did the first point. All right, let's go for the second one, B. What is the probability that, now we're doing number B, question B, number B. Find the probability that the difference is a square number. So we have an issue here. D is square. Right, we have an issue here. We have to change our diagram. We have to erase our highlightings and re-highlight the answers that we actually care about this question, or we actually care about for this question, right? So we want to find values that are square numbers. So instead of the primes, we want these ones. Square values, right? Square numbers. So look, 2 minus 1 is 1. 1 is a square number. 3 minus 1 is 2, so not a good one. 5 minus 1, 4, so a square number. 6 is not, 10 is not, 12 is not. All right. 2 is not. 1 is a square number. 1 is also a square number. 3 is not. How much is this? This is 7, right? So no. And this is 9. 9 is a square number. All right. For this one, 7, 6, 4, 2, 2, and 4. And for these ones, we have 14, 13, we have 11, right? We have 9, we have 5, and we have 3. All right, that's it. Those are the possibilities, right? The highlightings. So now we can answer the question here. What is the probability? Again, success over total. As usual, begin with the total. Total are 24 combinations, all the dots. And how many of those dots are the successful ones? Again, the ones that are square. So our highlightings, we have 1, 2, 3, 4, 5, 6, 7, and 9. 9. That's it. What is the probability that the difference is a prime number? 10 over 24. A square number? 9 over 24. And just like that.
It's not 8?
Grau, yes?
Is not 8 number?
Son 8, profe.
Sí, son
1,
8.
2, 3, 4, 5, 6, 7, 8. Yeah. 8 numbers. Sorry, guys. Thank you. I appreciate that you guys are paying attention. Thank you, guys. 8 over 24. Beautiful. All right. That's it, guys. That is our solution. And this is just the first one. In future classes, hopefully, if you guys ask for it, we're going to continue with the rest of the exercises. I'm going to stop the video here, and you guys are going to have the rest of the... No, the class begins at 7:30, right? No, the class begins at 7:30. All right, let me do this. I'm going to stop the video here, and I'm going to begin a new one for the second question. All right? How about that?